We can use limits to formally define asymptotes. Let's start by reminding ourselves of the definition of a limit. We have actually two definitions of a limit so far. One for when the limit as x approaches a of f of x is a finite number L, and a very similar one for when the limit as x approaches a of f of x is infinite. What we're saying when we say that the limit of f is equal to L as x approaches a is that we can guarantee that we can get as close to L as we'd like by choosing a sufficiently small interval around a. And then any value of x that's within that interval will produce a value of f that's within the specified range of L. And if we want to be closer to L, we just choose a smaller interval around A. And for the infinite limit, what we're guaranteeing is that we can get as large a number as we want for f as long as we choose a small enough range around A. So if we want all our outputs to be bigger than 1,000, we choose one small range around A. If we want them to be all be bigger than 1,000,000, we choose an even smaller range around A from which to take our x's. So here's a function with a bunch of asymptotes. Let's begin by looking here where x equals -3. And we'll look at the limit as x approaches -3 from the left. And as x gets closer and closer to -3, y gets very large, so that limit is infinite. And if x approaches -3 from the right, the same thing happens. Y gets very, very large, so that limit is also infinity. And when the two one-sided limits are the same, that's the value of the two-sided limit. So the limit as x approaches -3 is infinity. Now let's look over here at x equals 1. And let's first look at the limit as x goes to 1 from the left. And in this case, y gets very, very big and negative. So the limit is negative infinity. But if we approach 1 from the right, y gets very, very large. So that limit is positive infinity. And since the two one-sided limits are different, the two-sided limit as x approaches 1 does not exist. Having looked at that, we can now give a definition for a vertical asymptote. We say the line x equals a is a vertical asymptote of f if and only if at least one of the following is true. The limit as x goes to a from the left of f is infinity, or the limit as x goes to a from the right is infinity, or the two-sided limit is infinity. Or we can do a similar thing. We would also have a vertical asymptote in the case where the limit as x goes to a from the left is negative infinity, or it goes to the right is negative infinity, or x goes to a two-sided is negative infinity. In this case, the only x values that produce infinite limits are x equals -3 and x equals 1, so those are the vertical asymptotes. What about horizontal asymptotes? Well, we look out here as x gets very large positive or very large negative, and we see that the y values seem to be heading towards 2. So let's look at another definition of a limit that has a key difference from the ones we've looked at so far. Here, let f be a function defined on some interval a to infinity. So this is saying we're looking from any number we like and then out towards infinity. And we're imagining what happens as x approaches infinity rather than as x approaches a finite number. And if we say that that limit is L, we mean that we can get the values of f as close to L as we want simply by taking a large enough x. So we pick some x that's big enough, and from there on out, every y value will be within the specified closeness to L. And then that lets us define a horizontal asymptote. The line y equals L is called a horizontal asymptote of f if and only if Either the limit as x goes to infinity of f of x is L, or the limit as x goes to minus infinity of f of x is L. And in this case, the limit as x goes to infinity of f of x is 2. So that tells us that the line y equals 2 is a horizontal asymptote of f. We could try the same thing with the limit as x goes to minus infinity. That again, in this case, gives us 2, so we don't get another horizontal asymptote. We just get the same one, y equals 2 again. Okay, a few final notes here. Realize that a function can have a maximum of 2 horizontal asymptotes. There can be one horizontal asymptote that comes from x approaching infinity and one that comes from x approaching minus infinity. We saw in this case that there was only one because both of those two limits were 2, so we didn't get a second horizontal asymptote, just one. Second thing to note, a function can cross its horizontal asymptote. Look, it does it right here when x equals -2. The definition of a horizontal asymptote only has anything to do with what happens when x gets very large, positive, or when x gets very large, negative. Anything else can happen for values of x in the middle of those. The function is welcome to cross its horizontal asymptote as many times as it wants. And finally, if a function has a vertical asymptote of x equals a, it has a non-removable discontinuity at a. Recall that a non-removable discontinuity is one where the limit doesn't exist, and the limit as x goes to a of f of x equals infinity means that the limit doesn't exist because it grows without bound. So that's it on the connections between asymptotes and limits involving infinity.